Alright guys, so welcome back. We're going to start lesson 4.1, which is dealing with right triangle trigonometry and vectors and practicing some basic vector addition. So we've talked about vectors before when we talked about kinematics ideas such as displacement, velocity, and acceleration, but we didn't really get into a ton of the math. Like if you remember how to do it in that kind of work, then that's fine, but we didn't really get into two-dimensional ideas, and we're going to need to do that for forces because forces act in multiple directions. So we're going to go ahead and just review some right triangles. So right triangle trigonometry is really the main basis of vector addition. So so hopefully you've seen these ideas before. If not, we will go through them and you will understand them after this lesson. So you'll practice. There's multiple options to practice and check your work on. So for the first idea here, we have a right triangle. And a right triangle is one that has a 90-degree angle in it. So I'll just try to point out that right triangle. So this is the right triangle, and 90-degree angle is the one that has, it looks like a square in the corner. So this corner here is at 90 degrees. And again, this is probably stuff that you learned at some point in the past, and you just have to remember these facts. So there are three different sides of the right triangle. The one that is directly across from the 90-degree angle is the hypotenuse. The hypotenuse is also the longest side of the three. In a right triangle, we also label an angle. So this angle here that I just made an arc in red here, this is the Greek letter theta. So I'll type that out so you can see how it's spelled. So that is theta. And theta is a common variable that we use in physics to describe an angle. So that symbol there, which looks like a circle with a line through the middle, that is theta. So theta is important when we label a right triangle because based on where theta is, we can describe the other sides of the triangle. So going back to this labeled triangle down here, the side, so let me do this first. So this red side that I traced in here is the hypotenuse. The side that is across from the labeled angle theta, so I just drew that, that is known as the opposite side. And the third side, which is kind of just the one that's left over, so it's not the opposite, it's not the hypotenuse, it is the adjacent side. And really it depends on where theta is drawn as to where you would label these sides. So it doesn't always look like the figure that's here. You could write theta in the top in this corner where I just put a green dot, and it would switch the opposite and adjacent sides based on those definitions. Regardless of that, we're going to use a couple ideas to work through to find different ideas. So one of the things that we use is the Pythagorean theorem, which relates the sides of the right triangle. So a squared plus b squared equals c squared is the mathematical way that you describe it. C in the Pythagorean theorem is the hypotenuse. So the hypotenuse is always letter C. It doesn't matter if you call the opposite side A or the adjacent side A and the opposite side B or the adjacent side B, but it's basically one side, one of the smaller legs of the triangle squared plus the other smaller leg of the triangle squared should equal the hypotenuse squared. That's what you do. So we'll use that to do some solving for missing sides. And then we'll use these trig identities, which are sine, cosine, and tangent. And these identities just relate two different sides of a triangle and then the angle. So when you take the sine of an angle or cosine of an angle or a tangent of an angle, that is a relationship that is relating the opposite side to the hypotenuse, the adjacent side to the hypotenuse, or the opposite side to the adjacent. SOHCAHTOA is a common mnemonic device to help you remember how that works. So if you look at the first letter in each of these three nonsensical words, so, and toa. The first letter represents the trig function. So the S part here stands for sine, the C here stands for cosine, and the T for tangent. When you're taking a sine, cosine, or tangent, it's always of an angle, so that angle is going to be theta. And then you always have an equal sign next, and then the next two letters, the O, the A, or the O, represent the sides of the triangle, or there might be an H. So the second letter is the numerator, or the top of the fraction, on the opposite side from the sine function. or cosine function or tan function. So O stands for opposite, and the third letter is the denominator, so that is the hypotenuse. So if we were looking at cosine, it would be the adjacent over the hypotenuse, or if we were dealing with the tangent, it's the opposite over the adjacent. So we're going to need to be able to use all three of these trig functions, and I'll show you how to input it into a calculator. You want to make sure your calculator is in degree mode, because that's what we primarily work with in physics classes, degree mode. I will show you again using kind of an online calculator, but if you have questions about yours, if you just take a picture of it and send it to me through email, I can tell you how to get to degree to check to make sure it's in degrees. Okay, so this is kind of right triangle trigonometry, and we're just going to practice a couple of these with a right triangle or two. So let's go ahead and go to the next slide. And we use right triangles a lot in vector math, so that's why we need to know these skills, and this is really pure math, but we will apply it to physics and physical quantities and make it into a vector. So let's go to the next slide. So the next slide here is going to just go through a couple problems. So I'm going to start with these problems. This is in the documents for the week, so you can access them there and print them out and write on them if you want, or just look on the screen here or your own D2L screen. So what we're going to do in all of these cases, we're going to label the sides of the triangle. So we're going to label it as the opposite, adjacent, hypotenuse, and then we're going to solve for anything that's missing. So any of the sides that are missing the length of that side, or if we're missing the angle measurement, we're going to solve for that. So so let's start with this one up here. So this is the right angle. So this side over here is the hypotenuse. I'm just going to write H for hypotenuse. This is my angle theta, so across from theta, that's the opposite side, so 3.1 is the opposite side length. And then 5 is the third side. It's not the opposite, it's not the hypotenuse, so it's the adjacent. I'm going to write A for that. So hopefully labeling the triangle is good for you. That is the first step that you have to do in working with any right triangle. So now we're going to solve for the missing side. So side H here, the hypotenuse, we do not know the length of that side. So we're going to use the Pythagorean theorem and do that. So it would be something like 3.1 squared plus 5 squared, and then you take the square root to get C, because it was A squared plus B squared equals C squared, but we don't want C squared, we want C, so we're going to take a square root on both sides. If you do that, you should get a value of 5.88. So the hypotenuse, again, whenever you check your work or you're looking to see if your work is reasonable, the hypotenuse should be the longest side. 5.88 is longer than 3.1 or 5, so it seems okay. All right, let's go ahead and get into the angle theta, and this part is maybe the part that you're not as familiar with. So let me pull up an online calculator so I can show you how to input that. All right, so let's go ahead and try to figure out what theta is. And the way that you solve for theta is you have to identify what sides you know, and then use one of the trig identities on the previous slide to figure out what theta is. You could use any of them at this point because we've figured out all three sides, so we know the opposite, the adjacent, and the hypotenuse. I'm going to start with using the two sides that were given though in the problem, so that was the opposite and the adjacent. So if I go back and I look for, okay, which one of these three identities has opposite and adjacent, it's the tangent. So TOA, opposite and adjacent, tells me that I want to use the tangent identity. So I'm going to write the tangent identity out and plug into that and then solve. So heading back to where we were, it would be the tan of theta is equal to, and I'm just going to write O over A, so O stands for opposite and A stands for adjacent. So so it would be the tan of theta. We're going to look for theta. Is equal to the opposite side, so the opposite side we labeled as 3.1, and the adjacent side was 5. So we have this identity set up, and we're trying to solve for theta. So this is where you have to use a special key on your calculator, and let me try to pull up that calculator. Alright, so this is Desmos, which is an online calculator. If you like using it, you can. But we want to get theta all by itself. So to do that, we have to do what's called the arctan to get theta isolated. So it would be theta equals arctan, which it shows up on many calculators as tan to the -1 power, it looks like. Some people call it the inverse tan. It's not really technically the inverse tan, but if you did that, I would understand what you mean if you wrote that out or you said that in a statement. So it is really, if you're a math person, the arctan, but we'll let you slide on just saying inverse tan if that's better for you. So you're going to do that in the calculator, so you just have to set that up. So I'm going to go to functions here, and I want the inverse tan, or the arctan, of 3.1 divided by 5. And I'm going to close that up. All right, and then it says it's 31.79, and that is the correct answer. So theta in this problem was 31.79, and that would be degrees. Depending on your calculator and how you're using it and what type of calculator it is, it can require you to put like the numbers in first and then hit the arctan. If you can't find the tan or the arctan or the inverse tan, it's usually you'll find a second or shift key on your calculator and then hit the tan button. Again, if you're having any questions, if you don't get 31.8, try it a different way. And then if you're still not getting it, you might need to check to make sure you're not in radian mode. So if I switch this over, you can see it's in radian mode now. That's what RAD stands for. And it's a completely different value because it is a radian is a different measurement than a degree. So if you get that number, you just are in the wrong mode, and you just have to change it to degree mode. Usually that's in the mode function of your calculator. And again, if you have a specific question about your calculator, just ask me. Okay, so that is the first answer, and that's kind of working through labeling the triangle, solving for one of the lengths, and then calculating for the missing angle. So let's try another one. So I'm going to erase this stuff. And we'll do the same thing for number 4 here. So if I look at number 4, that's the 90-degree angle. So again, that's my hypotenuse. Same steps. I'm going to go across from my angle theta, and this side over here is the opposite side this time, so that is switched. And then 4.95, that is my adjacent side. So that's it. Label the triangle. That's always your first step. Then Pythagorean theorem. So it's 4.95 squared plus 6 squared equals the hypotenuse, which is usually in the Pythagorean theorem, it's c squared. So there's that. We're going to take the square root of both sides. When you do that, you should get a value for the hypotenuse of, shoot, I forgot to write it out. I'll just do it on Desmos here real quick, sorry. So, so it's going to be 4.95 squared plus 6 squared. It equals, and then I want to take the square root of the answer. So that is correct. So 7.77 or 7.78 is the correct value for this side here, 7.78. Okay. So again, rounding is fine. The next part is going to be repeating solving for theta. So we're looking for this angle theta and what that angle is. So again, we know the adjacent and opposite side, so that was what was given. I didn't make a mistake in calculating it or rounding it wrong. So I'm going to use the opposite and adjacent. So that's TOA again, out of SOHCAHTOA, so that's the tan. So it's really the same setup as what we did in the previous one. So tan theta is equal to the opposite over the adjacent. And that is typically when you're solving for an angle theta in our class, you're going to be using the tangent most of the time. So that's why I'm making you practice this one. So it'd be tan theta is equal to the opposite side this time, which is 6. And we're going to divide that by 4.95. And then, again, you got to get the tan to the other side to isolate for theta. And that would be the inverse tan, arctan, technically correct, but inverse tan I will say sometimes, and you will probably as well, because that's what it looks like, of 6 over 4.95. So we're going to get our answer here. It's going to be in degrees. It's supposed to be a degree symbol. And let's pull up Desmos to do that. Alright, so again, we're going to go to function, inverse tan, and then it's 6 divided by 4.95. I'm going to hit equals, and I got 50.477, so I'm just going to round that to 50.5. One thing I failed to mention last time, you can kind of get a feel for if your angle is correct. So the way that triangles work, the biggest side, which is always the hypotenuse, is across from the biggest angle. So this angle, again, that it's across from is 90 degrees. The next biggest side, which in this case would be 6, should be across from the next biggest angle. So this is 50.5 up here. And then the smallest side, which is the 4.9, is across from the smallest angle. So there are 180 total degrees in a triangle, so if this is 50.5, and we've used up 90 already, if you subtract 180 minus 90 minus 50.5, I think you'll get something like 39.5. So that seems to check out that the smallest angle in this triangle is across from the small side, the middle or median one is across from that, and then the largest side is always across from the largest angle. Okay, so let's go ahead and use our other skills and kind of work the other way. So I'm going to skip 20. I'm not going to do that one. And I'm going to do 22. So let me readjust kind of the mirror or the image of what's in focus on the screen. Okay, so we're going to work with 22 here. And again, it's the same way you start. So you start by labeling the triangle. So this right angle is there. So 14 is my hypotenuse. We also have our angle theta that is given to us. So we're not solving for theta this time. We're going to solve for kind of the two side lengths. So we're solving for this side here and this side here. So looking at if this is theta, this is my opposite side. So I got my hypotenuse, my opposite, the third side is my adjacent. So side AC is the adjacent side, and side BC or CB is the opposite side. So the way you're going to do this is you're actually going to use trig functions again. So you're going to use one of the three trig functions. I'm going to erase up here. And we know the hypotenuse and we know theta. So if we know the hypotenuse and we know theta, and we know the hypotenuse and we know theta, we're going to use the sine and cosine to find different sides. So again, sine opposite hypotenuse, cosine adjacent hypotenuse, they relate those sides and those angles. So I'm going to start with coming back to here, and I'm going to solve for, let's say we solve for the adjacent side here. So we're looking for this side. So the adjacent side, the hypotenuse, and theta are what we want. So let me take a quick snip to this, because I think that'll be helpful. I'll just get that. That's way too big, but we'll fix it. Okay, so we're going to use, for this adjacent side, we want the adjacent hypotenuse to get the cosine of theta. So we're going to write the cosine out. And I will just write that out here. So cosine, maybe not there. Let's write it up here a little bit. So the cosine of theta, which is 24, so I'm just going to plug in. So I'm using this relationship. So the cosine of 24 is equal to the adjacent side, which is just going to be, I'll label A. And I'm going to divide that by the hypotenuse, which is 14. So one of the things I want to make sure that you guys are aware of, the cosine of a number is just a decimal. So the cosine of an angle is just a decimal. So if you just want to get rid of that, you can pretty quickly. So if I just hit cosine of 24, it tells me that's 0.913. So I'm just going to say it's 0.91. So instead of having this term cosine of 24, it's not good for a decimal point. Instead of having this cosine of 24, you can just put 0.91 is equal to a over 14, and then this is a lot simpler for most people to solve. So you're just going to solve for a, so you're going to multiply both sides by 14, so it'd be 14 times 0.91, that's what a is equal to, and that turns out to give you, find where I did it, 12.8. So 12.8 is this A side of the triangle. We're going to do really similar work to solve for O. You could use a Pythagorean theorem at this point, but it's a little more tedious than what I would say you would do. So I'm just going to use the sine. So I'm going to use this sine function, which deals with the opposite and the hypotenuse, which are the two sides that are involved in this relationship, and theta. So I'm going to write that out. So I'm just going to move over to the right of this and work with it. So it'd be the sine of the angle, which theta was 24, still 24 degrees, equals, the opposite side is what we don't know, so I'm just going to label that as O. The hypotenuse is still 14. And again, we're going to do the same thing that we did last time, so if you don't like sine of 24, you can just put it in the calculator and say, okay, sine of 24 is equal to, whoops, writing it out instead of just hitting the button. Nope. Sine of 24. So that's 0.41, we'll just say. So 0.41 equals 0 over 14. We're going to solve for 0, so again, same kind of math. We're going to cross multiply or multiply both sides by the 14. So the opposite side is equal to 14 times point, that's supposed to be a multiplication sign, times 0.41. And for that side, you should get something like 5.7. Again, it should make the logical sense, like the longer side has a bigger angle. So if this is 90, 14 is the biggest side of the three, 24, this is like 5.7 for that angle. The other angle adds up to 90, so these two angles add up to 90, so that's going to be like 66. And this side was 12.8. So again, it should match up with that proportional check. So I'm going to stop there before we get into vectors, because this video has gotten a little long. And then we're going to talk about vectors and maybe just practice some basic vector addition, and you'll see how these skills are useful in the next one.